I'll introduce our last speaker. Felicity Meyer is a master's student in bioresource engineering, and she is going to be talking about the weight of our dear city of Montreal. With that, I'll pass you the floor.
Awesome. Hi, everyone. It's great to have you here to talk a little bit about my research. I do want to start by just posing a question. How often do you think about what you're eating? Well, for better or for worse, we need to eat so we can grow. And it's really easy for us to conceptualize that there's metabolic processes happening all the time, even if we only think about them from a really high level. But cities are kind of like living organisms in that way too. They need to take in resources to grow and function. But what if we just let a city eat whatever it wanted? What if it only ate things that were unhealthy? Or we just never kept track or thought about it at all? I know thinking of a city eating feels a little bit strange, but this is a field of thinking called urban metabolism. And if you think of a city in this way, it lets you ask the question, how heavy is my city? And in my case, how heavy is Montreal? Urban metabolism has been applied by researchers all over the world, sometimes at the country level, but also down to a very micro scale. And now the heaviness of a city is connected to both the types of buildings and the types of materials we use to make that city. We're all familiar with the saying, what gets measured gets managed, and that's absolutely true of cities. Just the sheer mass coming in to build them is enormous. And so understanding this data can be really empowering for citizens, industry developers, as well as policymakers, because we can't make cities more sustainable if we don't know how to feed them a leaner material diet. And really that starts with stepping on the scale today. If you can start asking those questions, you can ask, what have I been feeding my city? What emissions are associated with that diet? And what I think is really exciting, what could we feed it in the future to make it better? So what do we know so far? Well, as of a few years ago, a combination of construction and building operations hit a peak of 13.4 gigatons of greenhouse gas emissions. Now, that's equal to about 38% of yearly emissions, about half of which is just making materials to start. With increasing urbanization and a majority of greenhouse gases already coming from cities, it makes urban areas a really good place to start looking at how we can make positive changes in the future. Now, I do just want to put this into context a little bit. As a society, I think we've all kind of come to terms with the fact that flying is really bad for the environment. But if you break down the numbers a little bit more, the aviation industry actually only accounts for about 3% of yearly emissions. You know, I absolutely don't want to discredit that, but it does go to show that the building industry is really flying under the radar when it comes to the environmental harm that we're doing. So the materials that we use to build buildings are typically steel, concrete, and wood. Now, steel and concrete have historically allowed us to build what we imagine cities looking like today with tall and safe buildings. But extracting and producing those materials is just notoriously bad for the environment. On the other hand, wood seems a little outdated, but there is actually a new technology called engineered wood, which in the past few decades has shown really promising results in allowing us to build structurally sound and safe tall wood construction. So what would the carbon benefits of a tall wood building be? Well, one study found that if you modeled a building made of wood instead of steel and concrete, you could help save over 1.6 million tons of greenhouse gases between 2016 and 2030. Tall wood buildings feel a little bit off when we think about them to start, but like I said, this isn't just regular 2x4s that we're building with. These types of buildings are called mass timber and can be made from a variety of engineered wood products. One example that I have here is cross-laminated timber, or CLT, and here the boards are arranged in alternating perpendicular configurations and then adhered together. And so this allows us to make really big beams and panels that have fantastic mechanical properties and actually the structural integrity that's similar to steel or concrete, though a lot lighter. Still, wooden skyscrapers may seem strange and you might not want to stand at the top of one, but they're actually super safe. Because of the way that mass timber is engineered, it doesn't burn like traditional wood and has also withstood earthquake testing. So let's look at some real wood skyscrapers. The first example is Mjørnsene. This building is about an hour north of Oslo, and it's an 18-story mixed-use building that stands at over 85 meters high. The developers of this building estimate that the equivalent mass of wood that was extracted for the construction grew back in local Norwegian forests within 2 hours. A little bit closer to home is 80 Atlantic in Toronto, which was Toronto's first mass timber building, but absolutely it won't be the last. More projects are in the works every year. And then currently the tallest mass timber building in Canada is UBC's Tallwood House, which is 18 stories tall and only took 9 weeks to build. And then of course, a really exciting example is McGill's new Building Architecture and Research Node, or BARN. BARN is an architectural studio that'll be built on the Morgan Arboretum, or on the Macdonald Campus, with wood sustainably harvested from the Morgan Arboretum. And what I really love about this is that it shows it's not just big companies or developers that are working on mass timber, because BARN will be a living research project both for and by McGill. All right, so I know I've talked about greenhouse gases from a very simple perspective, so we need to dig a little bit deeper. On one hand, mining and producing steel and concrete uses a ton of fuel and energy and emits a lot of carbon dioxide. On the other hand, in a perfect world, a sustainable forest would help sequester carbon during photosynthesis and wouldn't result in those same greenhouse gas emissions, right? Well, that's not quite right, and is a little bit oversimplified because real systems are not always so simple. We have to look at a lot more than our carbon footprint when it comes to speccing materials, and really there's a lot more than meets the eye, which brings us to my research. So I work in the Sustainable Urban Rural Futures Lab at McGill. And what we do is look at cities and then develop advanced sustainability analytics to understand how they contribute to environmental change, and then try to dig deeper into how we can solve those challenges. This work ranges from supply chain dynamics to resource use across the country or even the globe, and also how environmental burdens are shifted from one community to another, and in particular, how urban regions can affect the rural areas that provide them with resources. More specifically, for my project, I'm going to try to answer these 3 research questions. First, how heavy is Montreal today? We want to understand what is the current building material stock across Montreal at a neighborhood level. And we'll focus on the most widely used construction materials, which will include steel and concrete. Next, based on population growth in various development scenarios, we'll try to estimate what type and how many buildings we're going to need between now and 2050. And that will include modeling different density scenarios and how many people are fitting into each dwelling. Third, based on those results, we can model the environmental impacts from different material scenarios. First, if we stick with the status quo and keep building with steel and concrete the way we have been. And next, if we change steel and or concrete for different types of engineered wood. Now, I want to reiterate that the impacts of this go far beyond greenhouse gases and climate change. We're going to be looking at a variety of potential problem areas to see how wood fares against steel and concrete in each category. All right, so at the end of this, we'll have put a nice little bow on this and answered all of our questions. Perfect. Well, there's actually one more piece of this puzzle that I think is really important to remember. For me, what drives this work is the idea of decision support. There are a lot of stakeholders that could really benefit from this data and help develop Montreal in a more sustainable way. But what I really hope is that this project helps you advocate for the kind of buildings, cities, and futures you want for your community. I'm really excited to be doing this research in a city that I love living in, and I hope that as I continue this journey, I'll be able to share more information about my findings. Thank you so much for your time. I apologize for the technical difficulties, and I'm happy to take any questions that you might have.